Hi everyone, my name is Rajsekar. I'm working right now at IIT Jammu at the CPMU as an adjunct faculty. I'm here to talk about evaluating social AI. So I want to keep this talk as interactive as possible. I wouldn't want to speak for 1 hour monotonously. So please feel free to ask any questions. I'll also make the slides a bit more practical and try to show you some demos. It would also be nice if in the last 15 minutes or so, if we have time, we can try to understand like data evaluation needs from all the NGOs, and specifically if any of these tools are useful, we can like brainstorm a bit more. Great. Let me get started. First, let's just think about what are the things we would want to evaluate. I really want you to tell me the answers, and we will try to like list all the types of evaluation we would want to do in a social organization. So broadly, these are the different categories I could come up with to evaluate, mostly using ChatGPT. And we will try to look at a few common practical techniques that are available in the open source world to solve all of them. We'll quickly start off with a sort of a theoretical primer on all of these to understand what we are talking about here. So there is no particular order in which I place these. Typically, depending on the maturity of the organization and the priorities, we would have to pick different things. For instance, when you're trying to establish the technology, the tech efficacy metrics are going to be more important. So we'll have to check the accuracy, the bias, and things like that. Towards the other end, where we are trying to create social impact and policy changes, it would typically be important to assess the impact and outcomes in a very quantitative way using trials or other things. So it really depends on the maturity of the organization and the priorities involved. So I'll quickly say, as I said, this is going to be slightly more on the data side, focus more on like using data to create what do you call it, insights. And so I'm going to quickly say why stats are needed. We really want measurable outcomes in the social sector to be able to analyze and reflect on our intervention. Specifically, what we are talking about is something like we have a user, we have an intervention, and we are able to measure this outcome before and after. And just using this, how do you claim that your intervention has provided some inputs, right? It's generally not statistically true that only your intervention caused this change. And a lot of the techniques we talk about here are kind of along the lines of like making this requirement rigorous. I could give an example. Yesterday, my significant other came back from a trip and said she was very happy for 2 days when she was not at home. It could be because of me or because of the home. Unfortunately, this conference is happening right now. So when I go back now, the answer will be clear because there is a differential experiment where I am outside. So these kind of things are what you would want to think through to set up good experiments. Really what we talk about in the stat literature is that we want to remove selection bias. So we don't want to pick users who might be more favorable or things like that. So the kind of gold standard here is to use what is called randomized control trials. The idea is that we randomly assign whether we provide a user an intervention or not and use that to assess the difference. But roughly what I'm saying is in the random control trials, we will have a set of users and we want to assign them randomly to the intervention or the control group. And the randomness is very crucial to avoid any sort of selection biases. Then the idea is that we basically measure the outcome after the intervention or the control, and we kind of look at the difference between these two outcomes. And now there is like some statistical proofs that say that a lot of the biases get cancelled because of the randomness and the size of the sample set. And this is sort of a gold standard that people use. There are specific techniques that people use after getting the values out of the intervention control also, specifically to calculate the statistical significance. So specifically, there are few tests like F test and T test. These are all, you don't have to understand the math behind it. The math is somewhat simple. Basically, you have a value that is obtained from the control and intervention, and these two values are hopefully different. But they have to be significantly different for you to infer something statistically, because the variance might be enough that there might be some difference anyway within the noise. And these kind of tests provide you scores to tell you how meaningful this measuring has been. These libraries are all available in most of the Python or other computer tools, so you can directly just plug this in and calculate this. We will see a simple example like this later in the talk. As I mentioned, the randomized assignment is crucial. One thing is that you don't have to make sure every person using the intervention has to be randomly selected or unselected. You can also form small groups. So for instance, typically in the way RCTs are used, they would group by geography. For instance, many educational studies would kind of assign a whole school whether to the treatment or not to, to the control group. The reason is also ethical reasons and practicalities, because typically what we are providing is a new innovative tool, and we should provide some choice to the students also to use it or not. So a completely random assignment is typically not practical, but the statistics allows you to group people into small enough groups such that the number of groups is enough. The number of groups will now play the role of the population in all the statistical calculation. Uh, there is a simpler version where when randomized control trials are not possible, there is also a different method called difference in differences. Um, this is not random. Here what we do is we have users and we might be assigning them in non-random way to the control and intervention. So what we do is not only do we measure the outcome at the end of this intervention or control, we also measure before and we take the difference and compare the difference. And the hope is that the difference has lesser of a selection bias. Um, it's a quasi-experimental design. This means that you have to kind of convince yourself that the difference in the scores does not have selection bias. That's something you will have to qualitatively understand. Typically, this is easier to implement because this involves longitudinal studies, which means you take one user of the platform, study them for a year or so, and you will have different time points where you can take readings using some measurable outcomes. As I mentioned, the selection bias has to be carefully understood and cancelled out. There is one specific idea called regression designs where people would typically split between the intervention and control based on some cutoff score. So for instance, people who have passed with distinction might go into one program and other people might go into other program. And here the cool idea is people very close to the cutoff typically are similar in biases. So there is probably no difference between people who just cleared this exam and just did not clear the exam, which means you can use them and do some sort of study. So you can apply the RCT kind of stuff on the sample that's only around the cutoff, and typically you would have some good analysis of how the intervention worked out. And of course, as I mentioned, qualitative analysis is also very important. There are a bunch of different methods like user studies, focus groups, case studies, participatory designs. The main thing about qualitative assessments is that it gives a great semantic understanding of the problem they are facing. Specifically, it will be very easy to identify negative things, for instance, what won't work for them. And so this should kind of be used complementarily with the quantitative analysis to give you a complete picture of the social sector. I will move now into the tech efficacy metrics because that's also something very crucial for our group here. Um, specifically, I think the Langfuse group has covered, the Langfuse talk must have covered a lot of things about setting up specifically tech efficacy metrics for AI chatbots and AI interventions. So I will try to step away from that and try to talk at a more high level. Typically, you would want to solve performance metrics initially to ensure that the technology you are building are actually usable for the social intervention that is being planned. So these are going to be very important. One suggestion I would say is to try to use as much as possible open source frameworks that are already available rather than building from scratch. So that's what I mean by start complex, not, just in this context really. That's because there are a lot of, especially with the Gen AI boom in the last 2-3 years, lot of technology that was slightly taking more time. The cycles have compressed a lot now. So it would make a lot of sense to use that and try to build more POCs using latest LLM models or vision models before trying to fine tune and create an optimized model later on. Another thing, when you're starting off with the tech feasibility, the UX is a really important, crucial thing, especially in the social sector, because we are trying to reach audience who are probably not very tech savvy. So for instance, so it will also be, I think the UX metrics are very important, as important as the performance metrics. For instance, it is not clear whether you want to improve the accuracy from 80 to 90 or the response time from, I don't know, 5 seconds to 1 second. It's really, there is no clear winner here. It really depends on the social organization that's working on it. So it will be useful to think about the end user when we are like designing these tech efficacy metrics. So finally, there is also scalability and economics, where basically once we have the feasibility established, we can optimize and try to figure out what will be the cost per intervention for a scale, for a city scale or a country scale. Then again, on the tech efficacy side, there's bias and fairness. This is very important in the social sector. So we want to have techniques to identify and mitigate them. I think the first step would be to like collect data sets really. That's kind of the first step, because there are a lot of good tools available once you have that. For instance, FairLearn is an open source tool, if you have seen it. So FairLearn is an interesting tool where it has a bunch of existing APIs to, it's a easy to install Python tool that you can use to immediately check for biases. For instance, here they're looking at something in the health sector where they kind of assume that a readmission of a patient within a few weeks probably implies that they weren't treated properly in the first time they visited the hospital, and they try to plot that against different race indicators they have from the data set. So things like there are already good metrics available in the open source community that you can immediately use once you have data sets for this. Typically, the number of different bias and fairness things can be kind of reduced to 3 categories. It's probably on geography or on some ethnic things, or probably some regulatory conditions from the specific social sector you are looking at. So if you can get data sets with any of these indicators, it will be very easy to analyze them and work with this. Specifically, when you're using AI technologies, it's important to look at the low resource languages support and things like that, because typically the AI interventions have are not might have different performance on languages where they had lesser training data. So that is something you would want to keep in mind, specifically in the social sector where we are trying to reach specific marginalized communities. Finally, we have the robustness thing, where we want to also check the AI evaluation. AI systems we are building are not they are kind of hack proof. This kind of similar to the penetration testing kind of things that people used to do with cloud technologies to check whether the server is going to be attackable to get data about the users and things like that. Even in the social sector, since the data might be sensitive, it's important to ensure that the AI systems are not kind of providing these kind of, allowing these kind of attack vectors to surface. Specifically, there is again like a very good tool called PromptFoo. This is again an open source tool where you can install, and it already gives you a lot of things like it already provides you checks against things like prompt injection and common vulnerability attacks. They are also connected to the OWASP community, which is an open source, open consortium of security issues that come up in cloud computing. So they tend to have like up to date ideas on attacks and ways to prevent it. So it will be very useful to check this when you are looking at biases. Azure and AWS also have a lot of red teaming APIs. For instance, Azure has Microsoft Red Team, which you can definitely try out if you have data lying in the Azure system. Definitely, when you are deploying the AI intervention at scale, some sort of continuous monitoring is very useful to prevent these kind of attacks in a real time. One more thing you can use when you're trying to use open source models is the transformer models these days have some measures like perplexity, which can tell you how uncertain the model is about specific answers. So you can use, you can do some experiments on that to see if that is improving the robustness of the AI interventions you're using. One more aspect that was even spoken about in this cohort was explainability. There are very good standard open source tools. SHAP is a very common tool that's used for structured models. SHAP is based on some game theoretic model to define, let's say you have inputs and you get output classification on whether it's a yes or no. SHAP can do some computations and give you which of these inputs had what weights on it. There are a lot of formulations of this. SHAP is one of the more common ones that's prevalent. There is some use of SHAP in transformers also, but I think it's fairly recent. SHAP is more designed for decision tree kind of algorithms. So if you're using those kind of algorithms in your model, go ahead and use this. Lime is another example, which again is another formalization to understand how important each input was in deriving some output. You can check it out. Lime also works on transformer models. Like if you have a BERT-based classification model, you can use Lime to understand which words or which tokens were important and things like that. In general, in the social sector, you want to try to get user-centric explanations, especially if you are using LLMs. It's somewhat easy because with the big LLMs like GPT kind of models, you can get the answer and give it back to the model to understand, ask it to only introspect on the output, and the large language models typically do it quite well. Now I'll go to this kind of a theoretical primer on the kind of different evaluation methods I've seen. We'll kind of look at a more practical guide of how we would go about analyzing data. I'll specifically only stick to the exploratory data analysis, which means you have done some tests on social impact and you want to analyze that kind of data. I will again mainly cover good open source technologies that are available and a few platforms built on these open source technologies. There are definitely a lot of different platforms. I'm sure Tech4Dev's Dalgo platform is also one of a tool for doing exploratory data analysis. So for instance, I was looking at the RCT trials data from Pratham. This is available. There are a lot of good data sets available on JPAL. JPAL is Jameel Poverty Action Lab. They have a very good open source data sets. This was one of the examples I had seen, and I have downloaded it on Sheets also if anyone wants to open it up. So I'll just quickly go and give an overview of this specific data set. It was collected by Pratham, I think their education NGO, and they were doing a few programs, specifically something called TARL, which means teach at the right level. So they try to understand the students' learning level at the time and try to provide intervention based on that. This was a very fairly famous randomized control trial that was done in India. Mainly there is a control group and 3 different treatments they have tried. As I mentioned earlier, they kind of group into villages. So they have, I think in the data set, they have about 150 schools and roughly 40 for each group with 4 groups. So, so one of the main things about practical data analysis is that you want to figure out the data engineering aspect, specifically how you would ingest the data coming from the programs teams and other teams from the organization and have a consolidated dashboard. This could be done by tech partners, but typically these days there are a lot of open source tools available. So it will be beneficial to at least do a first primer on that before getting tied into one specific platform. Or even if you are evaluating many different platforms, it's useful to see who is more open source friendly to see kind of whether you will get logged into one specific platform or not. So specifically, I found Superset was a great example. I saw there's an open source software from Apache. It directly runs on Docker, so there is no installation you need to do, just have to download and run it. And once you have it connected, I have connected it to many different data sources like Postgres, really any database, relational database it can connect to. I've even tried Azure Databricks and it works seamlessly with that. It's a very good open source technology that you can use. And there is also a platform hosted version of it called Preset. So here, for instance, I had tried out this Bihar dataset, the dataset from Pratham specifically on Bihar. It seamlessly connects with Google Sheets also. So if you have your data on Google Sheets, you can easily just import them as datasets here. And then this sort of a open source version of Power BI. So what you can do is ingest data from different data sources, make it run ETL, which means extract using SQL, do some simple transformations and produce graphs. So these things can be done very well here. So I think it's a great tool to do exploratory, like initial level data analysis, to do what kind of data you would want to collect and what kind of analysis you would want to do at like a POC level. So again, this preset is sort of a hosted version of this superset, but I found superset as usable. The preset, the only extra thing is that you can use it without having to do any installation. So you can just use it as a platform. But if you are somewhat tech savvy, I would suggest to just use the superset, which is just a Docker. You can just run it on your computer, and it should allow you to work with it. Exactly what was summarized. So we have Julius AI and Google AI, and there are a lot of code writing tools like Colab and Copilot and other things that also let you do a lot of basic data analysis quickly. So really what I'm trying to push here is that given the recent Gen AI boom, there is a lot of easier tooling available to study data. Specifically also these kind of structured data, there are a lot of natural language to structured query kind of setups. We should totally evaluate them to quickly get a sense of what data you have and what are the insights you can derive from it. I think at a larger level, what I have seen in different social sectors is the line between program team and tech team is slightly disappearing. I've seen like big organizations, the MEL team themselves would have data scientists who would be able to use these kind of tools and quickly give them dashboards. They would never reach out to the tech team to do it, because the tech team is typically their bandwidth is mostly consumed towards building new functionalities to demo, to show and send to the users. That's where these kind of new Gen AI tools are bridging the gap, because they kind of empower the programs team who have good conceptual knowledge but lesser tech knowledge to kind of do a first level data analysis so that the insights are obtained faster.